Hey guys, welcome to Conceptual Geometry, Lesson 3.9, Properties of Trapezoids, including Isosceles. You're going to need your white note packet for days 9 and 10 and your blue shape packet. And what I'd like to do first is go to the trapezoid shape. What I'm going to do, I'll measure the sides with my straight edge and tell you guys how many millimeters I'm getting, but obviously your distances might be different, but we're just looking for relationships here. So this bottom side, I got 127 millimeters. The top side, I got 86 millimeters. So obviously those are not congruent. This here, I got 73 millimeters. And this one here, I got 83 millimeters. So no relationship whatsoever with the sides. All four sides are different. That doesn't mean that they have to be, but they're not necessarily going to be congruent either. Okay, with my protractor, I'm going to measure this angle down here. I got 60 degrees. And I'll measure this one over here. I got 75 degrees. So no apparent relationship between those angles. This angle up top here, I got 120 degrees. And this angle here, I got 105 degrees. So again, no relationship between these angles whatsoever. But there is an angle relationship here. If you notice, the bottom left and the top left add to 180 degrees. The bottom right and top right add to 180 degrees. So there is a relationship there. Before we go on to the next shape, isosceles trapezoid, let's go to our note packet and write in a couple of our observations. Now, you can't measure parallel, but you can tell that the top and the bottom are parallel. So we're going to say this has exactly, that's important, one pair of parallel sides. And it's going to be the top and the bottom. Exactly means no more, no less. So it can't have two. If it had two, it would be a parallelogram. Trapezoids are not parallelograms. If it didn't have any, it's not a trapezoid. And then the other property we just discussed is that the adjacent, I'm going to call them transversal angles, add to 180 degrees. So if I number the angles in this figure, 1, 2, 3, 4, what I know is angle 1 plus angle 2 equals 180 degrees, and angle 3 plus angle 4 equals 180 degrees. But there is no relationship between 1 and 3 or between 2 and 4. So if you're on the same side, or the transversal, this is a transversal, these two add to 180, and then on this side, those two add to 180. Okay, well, trapezoids are really, there's only one property, so we don't really work with trapezoids a whole lot. What we do instead is we deal with isosceles trapezoids. So before we get to the specific isosceles trapezoid properties, let's list the first two that we know it must have. It has to have the two properties from up above. So that would be exactly one pair of parallel sides and adjacent transversal angles add to 180 degrees. But there's got to be more. So let's go to our shape packet and let's go down to the last shape, isosceles trapezoid properties. Okay, so once again, I'm going to use my straight edge. This one right here, I got 144 millimeters. This top piece up here, I got 98 millimeters. And this one here is real close. I got 102. And then this one on the other side, I got 102. So first observation, these two segments are congruent. Measuring the angles, this is 60 degrees. And I know this one's got to be 120. I didn't even measure that one. I'm measuring angle C, and that's also 60 degrees. And I know that's got to be 120. So now I've got equal angles. these two are now equal on the bottom, and these two on the top are equal, in addition to the same side angles adding up to 180. Okay, so one more thing I'm going to do, I'm going to sketch in the diagonals. I'm not going to put it in the diagram because it's a little cluttered. Well, maybe I'll put it down here. I'm going to measure, oops, sorry about that. I'm going to measure DB, and I'm going to measure AC. All right, so using my straight edge, I'm measuring DB. I got 132 millimeters. I'm going to measure AC, and that's also 132 millimeters. So it turns out that my diagonals are also congruent. But clearly, I think you can see this, they don't, I'm not even going to measure it, but they don't bisect each other. Because look at this segment right here, this piece of the diagonal is much longer than this piece of the diagonal. So those two pieces are not equal, which means this is not a midpoint. All right, they don't bisect each other. All right, so let's add those properties. All right, so what else do we know? The non-parallel sides, which from here on out we're going to call legs, are equal. Non-parallel sides are equal. I also know that my base angles are equal. Now the base angles, there's two sets of base angles. Base angles aren't just the ones on the bottom. So what I would say here is that angle D equals angle C and angle A equals angle B. So if I'm marking in the figure, I know these two are equal, A and B, and angle D equals angle C. I also know these two sides are congruent. I'll do that in blue. And that's what makes it isosceles. In addition to that, these sides are parallel. The non-parallel sides, so that'd be these, the legs, are the equal sides. And that other property we just mentioned about the diagonals, the last property is that property about the diagonals. They're equal. Diagonals are equal. Okay, so this here is equal to that there. And then don't forget, those legs are congruent as well. So, how does a trapezoid differ from a parallelogram? It only has one pair of parallel sides. No more, no less. Okay, let's do a couple examples, and then we'll call it a day for 3.9. In trapezoid ABCD, so notice again, it doesn't say isosceles, it just says regular old trapezoid. If the measure of angle A, so I'll fill that in the diagram, is x plus 50, and the measure of angle D is x, find the measure of the two angles. Well, we know they're not equal, right? Obviously, this is acute and that's obtuse. And in geometry, in this course in particular, when one angle is obtuse and the other one's acute, chances are those are going to add to 180. And just a quick review up top, adjacent transversal angles add to 180. So that's what we're going to do here. X plus 50 equals 180. I'm going to subtract 50 from both sides. X plus x is 2x, so I get 2x equals 130. Divide by 2, x equals 65. Now the question wants to find the measure of two angles. I'll just put it right in the figure. That's 65. And 65 plus 50 is 115. So I found those two angles. All right, let's just do two more. So now I'm talking about an isosceles trapezoid, MJKL. It already marked these sides equal. All right, and it says if the measure of angle MJK equals this, and JKL equals that, find the value of x, and then find those two angles. Well, what we know in an isosceles trapezoid that these two base angles are going to be equal. All right, so if one of them is 4 times x plus 5, we set that equal to the other one, which is 3 times x plus 15. So the algebra here is going to be a little bit more challenging. They're just throwing in the distributive property. So don't forget you have to multiply both of these by 4 and both of those by 3. So this is going to be 4 times x is 4x, plus 4 times 5 is 20, equals 3 times x is 3x, plus 3 times 15, which is 45. So now we'll subtract 3x from both sides. I'll subtract 20. That's going to give me x here, and 45 minus 20 is 25. So x equals 25. Now, if I want to find the measure of angle MJK, that's this one, all right, I have to plug into this expression right here. So the measure of angle MJK is going to be 4 times 25 plus 5. 25 plus 5 is 30. 4 times 30 is 120. I didn't need a calculator for that. So this angle up here is 120. Now the next one, it says find the measure of angle JML. Well, JML is this angle down here. It's not the one that's equal to it, so it's not 120. But to get that, it's pretty easy. I know that these two angles have to add to 180. So to get this one, I'm just going to take 180 minus 120, and that's going to be 60. And that's got to be 60. Our last example, example 3. Given isosceles trapezoid MJKL, if JL is 2x plus 17, so here's JL, that's a diagonal. MK is 3 times 2x minus 11 plus 2. That's this diagonal. Find JL. So I'm not going to label the diagrams. They'll be a little too cluttered. Unfortunately, I didn't make this diagram big enough. But I know the two diagonals are equal. So if I'm given the two diagonals, I'm just going to set those equal. 2x plus 17 equals 3 times 2x minus 11 plus 2. Don't forget that plus 2. This is the whole diagonal here. They're just stepping up the algebra a little bit. I want to distribute, combine like terms, and then start solving this equation. So this gives me 2x plus 17 equals 3 times 2x is 6x. 3 times negative 11 is negative 33 plus 2. So I get 2x plus 17 equals 6x. Combine those in the calculator, that gives you a negative 31. Let's subtract 2x from both sides and add 31 at the same time. That gives me 48, and that gives me 4x. Divide by 4, so I'm running out of room, but x equals 12. The question wants you to find JL. Okay, well, JL is going to be 2 times x, so 2 times 12 plus 17. Throw that into your calculator, and I got 41. Okay, so we'll stop there for day 9. Day 10, we'll just continue these notes, but you have more than enough information to do the Delta Math homework for day 9. And as usual, guys, if you have any questions, do not hesitate to reach out. Thanks for watching.